Welcome to this session. Today we are going to discuss the permutations and combinations. So in the last class we discussed about the product and sum rule. The permutation means, suppose if you are going to perform n tasks or tasks one after the other. Let us say we are going to we are arranging R objects from n, and we are going to select in first object in n ways, and remaining n minus 1 numbers will be there. So remaining n minus 1 we are going to select n minus 1 ways, and next n minus 2 ways, and so on. So R items we are going to select. So it is n minus R minus 1. It is nothing but R minus half R minus 1 is R plus 1. So here we are going to choosing the first object in n ways. This is done in n ways. N minus ways we are going to select the second object. N minus 2 ways we are going to select the third object, and so on. N minus R plus 1 ways of choosing rth objects. It follows by the product rule of counting. The number of different arrangements are nothing but the permutations. Different arrangements are nothing but the permutation, and which is called a permutation, and which is equals to n1 into n1 minus 1, n2 minus 1, and so on, n minus R plus 1. So this is going to be denoted by P of n minus R, P of n of R. So permutation of n comma R. R we are selecting, R objects we are choosing from n. So the total number of permutations are, it is nothing but n into n minus 1 into n minus 2, and so on, n minus R plus 1. So numerator, denominator, we are going to multiply with this number. So then we are going to get the numerator will become n factorial. Of course, the denominator will be the same as usual, n minus R factorial. So selecting the R objects, distinct R objects from the n objects, we are going to take it as npr, or this is going to be denoted as n factorial by n minus R factorial. N minus R factorial. See here, suppose it is required to find the number of permutation that can be formed by the collection of n objects, of which n1 are of one type, n2 number are of another type, nk of kth type, then n1 plus n2 plus and so on plus nk is equal to n. Then the total number of permutations are n factorial by n1 factorial into n2 factorial, and so on, nk factorial. That means some items, let us say some items are repeated n1 times, and some items are repeated n2 times, and some items are repeated nk times. And of course n1 plus n2 plus and so on, which is equals to the total number of objects n. In such a case, the total number of permutations are nothing but n factorial by n1 factorial into n2 factorial, and so on, into nk factorial, So now we are going to discuss some of the examples based on this. How many different strings of length 4 can be formed by the letter flower? See here, how flower is consisting 1, 2, 3, 4, 5, 6 letters, and all 6 letters are designed. Out of 6 letters, we have to select 4 letters. So that is nothing but 6p4 ways we are going to select. Or nothing but we are going to represent in this way, p of 6, 4 also we can select, for selecting 4 elements from 6 6. Or we can denote it as NPR. NPR. N elements we are going to select. From element, N elements we are going to select R elements. So here 6 P4, 6 factorial by 6 minus 4 factorial, that is equals to 360 number of strings that we are going to get of size 4. And the next one is find the number of permutations of the word success. Find the number of permutations of the word success. So success is consisting 7 letters, which is having 7 letters. And whereas here some of the letters are repeated. C is repeating 2 times. S is repeated 3 times. And then U is 1 time. And the next E is 1 time. So 5 to 7. So now we are going to whenever see, suppose if the number of elements which are identical, n1 of one type, n2 of other type, the total number of permutations are n factorial by n1 factorial, n2, n2 factorial, and so on. So here in the success letter, so the number of permutations of this word, so here C is having 2 times repeated, S is 3 times, and of course U and E are 1 time. Then the total number of n factor, that is sum, is nothing but is equals to the total number of letters. So n factorial by the repeated letter 2 factorial, and next 3 factorial. It is repeated n1 times, and it is repeated n2 times, and it is repeated n3 times, it is repeated n4 times, n1 plus n4 and so on is equals to n. Is equals to n. Subsequently you can get 420. Subsequently you can get 420. Now let us go for the other way in the same way. See, this is the how many 9-letter words can be formed using the word difficult. 9-letter words. See how many letters it is having? 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. It is having 9 letters. Out of which D is. So here D is only 1 time, and the next I is equals to I is repeated 2 times. Next F is repeated 2 times, and the next C is 1 time, and U is 1 time, L is 1 time, and T is 1 time. So total 5, 6, 7, 8, 9. So 9 letters will be there. So now some of the letters are repeated. So the total number n factorial by 2 factorial, 2 factorial into 1 factorial, 1 factorial, and so on. So finally we are going to get 90,720 total number of letters of 9 digits. Now the other one is how many words can be formed using 3 letters from the word delay. So here 1, 2, 3, 4, 5. This is having 5 letters, and all are distinct letters. All are distinct. So how many ways I can form? 3. So here 5p3, which is nothing but 5 factorial by 5 minus 3 factorial. So which is equals to 5 factorial by 2 factorial. So it is 5 into 4 into 3 into 2 factorial by 2 factorial. Subsequently, so it is nothing but 60. So now the another one is how many words can be formed by using the letter word driver, such that all the vowels are always together. All the vowels are always together. See here, how many vowels are there in this? How many vowels are there in this? A, E, I, O, U. So here, so I, E. These are the 2 vowels. And of course the remaining D is there, R is there, V is there, and of course R is repeated 2 times. R. So 1, 2, 3, 4, 5, 6. So it is 6 letters. Now, see here, always what we are saying that always 2 vowels are together. 2 vowels are together. So I am going to consider this is 1 only. Then this is second 2, 3, 4, 5. So here how many arrangements will be there? 5 factorial by. So how many repeated? R is repeated 2 times, so it is 2 factorial. D is 1 time only. V is 1 time only. V is 1 time only. So I am getting this is, of course this I am taking it as 1 only, so 1 time only. So 5 factorial, this is nothing but 5 into 2 into 3 into 2 factorial by 2 factorial. These two get cancelled. So it is nothing but 60. So once again I am going to get 60. Now here the 60 arrangements are possible. Now once I am taking IE is together or else EA is together. So I am going to arrange I and E, the vowels, whatever the vowels will be there, the vowels in how many ways I am going to arrange. So here only 2 vowels are there. So it is 2 factorial ways I am going to arrange. So it is nothing but 2 ways. So the total number of arrangements are 60 and the vowels are arranging in 2 factorial ways. So the total number of arrangements are 60 into 2, that is 120. That is 120. Now the other one is find the number of permutations of the letter word. This is. In how many of these are 4 consecutive 4 A's together? 4 A's together. How many of them are begin with S? How many of them are begin with S? So here how many of these all 4 A's are together and how many of them begin with S? So here three problems will be there. 3 problems will be there. So we have to discuss one after the other. See here, how many number of permutations. So here, this is consisting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is nothing but 10 factorial by, see here M is repeated. M is only 1 time. A is nothing but 1, 2, 3, 4 times it is repeated. And next S it is 1, 2, 3 times. And U is only 1 time. S is U, okay. G is 1 time. So 5, 5, 5, 10. Okay, it is 10. So the total number is 10. So this is 1 factorial into 4 factorial into 3 factorial into 1 factorial into 1 factorial. So these many arrangements will be there. So that is nothing but 25,200. So this is without only the number of permutations. The number of permutations from the word, this word. From this word, the number of permutations. Next, in those words, how many of these 4 consecutive A's will be? So 4 A's will be, I am going to consider in one way, because the A's are 4 times will be there. So 4. And the rest of the things I am going to take the remaining things. M, S, 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 and A is already over. U, G. So 4, 5, 6, 7, 8, 9, 10. So now, how many letters will be there? Here, all A's together as 1 only. 2, 3, 4, 5, 6, 7. So this is 7 factorial by, and repeated. How many repeated? 3. S is 3 times repeated. But I am not considering because I am going to get the permutations. All the permutations are A's are together. A's are together. I am not going to consider. M is only 1 time and S is 3 times and U is 1 time and next G is 1 time. G is 1 time. So now 7 factorial by 3 factorial, which is equals to 7 into 6 into 5 into 4 into 3 factorial by 3 factorial. So get cancelled. So finally this is the final result. So it is nothing but 840. And next another one is how many of them begin with S? How many of them begin with S? So begin with S, once again I am going to consider all S's are together all S's are 3 S's are together. Next 4 A's will be there, and next another one is M will be there, and U will be there, and G will be there. See here, this I am going to consider 1, 2, 3, 4, 5, 6, 7, 8. What is that? How many of them begin with S? How many of them begin with S? So this I am going to consider as 1 only. 2, 3, 4, 5, 6, 7, 8. Okay, and now there are how many S's are there here? Okay, I am going to take S like this. Okay, how many of them are 4 A's are together? How many are, this is yes, S's are begin with S. This S may come here, or may come here, or may come here, or may come here, like that. So I'm going to consider S, and next yes, and next 1, 2, 3, 4, and next M, U, G. So 1, this is fixed, and 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to take it as 9 factorial by, here how many S's are repeated among that? 2 factorial, and this is 4 factorial, and then M, U, G, 1 each other. So I'm going to get only 9 factorial by 2 factorial into 4 factorial. Subsequently, we are going to get the result as 7560. So this is the other problem. And now let us consider the next example. How many positive integers n can be formed using the digits? Digits are given, and the condition is it should exceed, so 50 lakhs, let us say 50 lakhs or 5 million. So it should be exceeds this number. By using these numbers, we have to construct. See here, which is consisting 1, 2, 3, 4, 5, 6, 7, and of course here also 2, 3, 4, 5, 6, 7. 7 digits are there. So those 7 digits I am going to arranging in this form. x1, x2 and so on, xn, x1 into x2 into x3 into and so on, xn, x7. Now the thing is, x1 is nothing but the first digit, x2 is nothing but the second digit, x3, whatever the digit that you are going to select. It is going to select 3, it is going to select 4 or 5 or 6 or whatever it is, x1. x1 you can select any one of above digits, and x2 you can select any one of the above digit, like that. So now the condition is, it is given the condition as it is greater than this number. So greater than this number means x1 should be started with 5 or 6 or 7. Because whenever if you are going to start with these numbers, then only it is exceeds, otherwise it will not exceeds. So we have to select x1 as 5, 6, 7. Now let us consider, if I am taking x1 as 5, then the remaining 6 arrangements. So I am going to fix 5, 1, 5 here, and the remaining, how many are there? 4, 4, 5, and 1, 5 is fixed, and the next 6, and the next 7. 1, 2, 3, 4, 5, and another one is 3, 6. So 1 is fixed, 5 is fixed, and the remaining number, how many possible arrangements are there? There are 6 in number, so it is 6 factorial by, so it is 4 is repeated twice, so it is 2 factorial, and the remaining are not repeated. So this is 1 factorial, and the next 5 is also 1 factorial, 6 also 1 factorial, 7 also 1 factorial. So 6 factorial, 6 is 5, 4, 3 and 2 factorial by 2 factorial. So these many ways, that means we are going to get, so what is that value is 6 factorial by 2 factorial, and so it is nothing but 360 I am getting. 5, 30, 30, 120, okay, 360 I am getting here. So if I start with 5, similarly if I start with 6, then this is starting with 5, and if I start with 6, then 3, 4, 4, and 5, 5, and the next is 7. So here the number of arrangements, 6 factorial. Here 4 is repeated 2 times and 5 is repeated 2 times. So 6 factorial, 6 into 5 into 4 into 3 into 2 factorial by 2 factorial into 2 factorial. So these two get cancelled, these two. So 30, and then it will become 180. So it is 180. So similarly, if I am taking 7, so same thing I am going to get C. So now what are the, if I start with x1 as with 5, then what are the possible arrangements, possible numbers? And if I start with 6, what are the possible numbers? If I start with 7, what are the possible numbers? Now, what is the total number is nothing but just adding these 3. So 360 plus 180 plus 180. So it will become 720. So in this way, we are going to find out this. Now let us go for the another example. In how many ways 6 men and 6 women can be seated in a row if any person may sit to any other? There is no condition. If any person may sit next to any other. So either you can sit, men will be there, and then there is no restriction. Any person may sit next to anyone. If men will be there, then again men will be there, or women will be there, or woman will be there, like that. Okay. So there is no conditions. And next, if men and woman must occupy alternate seat. That means whenever men will be there, then automatically woman should be there. Whenever men will be there, woman should be there. Or woman will be there, then men should be there. So here, there is a 2 combination will be there. So first of all, we have to fill with men, next men, woman, like that. Or the second possibility is woman, men, like that. So that is there here. Now the first condition, there is no condition. So 6 men and 6 women, 6 men and 6 women. In any order we can arrange. So 6 men, 6 women is 12 members total. 12 members in any form we can arrange as. So 12 members can sit in 12 factorial ways. So it is nothing but these many ways that we are going to first in how many ways that we are going to 6 men and 6 women, if there is no condition, these many ways. Second one, if I am considering the men and women. So first one is men I am taking, then woman, then men, then woman, and so on it will be continued. First woman I am taking, next men, next woman, next men, and so on it will be. So this is one possibility, this is another possibility. So suppose if I am considering men will be first, men occupy 1, 3, 5, 7 and so on positions. 1, 3, 5 and so on positions. That means it is nothing but 6 positions will be there. 6 positions automatically we can arrange in 6 factorial ways. 6 factorial ways. And the woman is even places. 2, 4, 6 and so on. This is also 6 positions will be there. In these 6 positions, there are 6 factorial ways we can arrange. So in the first arrangement, there will be these many arrangements will be there. And similarly, in the other arrangements, if I am taking odd places, if woman is occupies, then earlier first one is woman occupies even places, and here woman occupies odd places, men occupies even places. which is also similar to the same number. So I am going to get the total number is this. The total number is this. So here there is no constraint, and the second one is there will be a condition. There will be a condition. See here, alternatively, men, women are sit together. Men, women are sit together. Either first one is men if we sit, or woman will be said followed by woman, men, woman, or men, woman, men, like that. It will be continuing. Now, the other one. Find the different mathematics books, 4 different mathematics books, 5 different computer science books, and 2, see here, 4 mathematics books and 5 computer science books, and next 2 control theory books will be there. Then the question is, how many different arrangements are possible? First one is the books in each particular subject must be together. That means whenever mathematics will be there, mathematics, how many ways we can arrange among themselves? 4 factorial ways. If computer science will be there, there are 5 books are there. 5 books, how many ways I can arrange? It is nothing but 5 factorial. Control theory is 2 books, so it is 2 factorial ways. So the total number of ways, see here it is given, the books in particular subject must be together. Always the mathematics books, if you are considering, all books are together. Next after that, computer books together. Everything, first maths, computer science, control theory, or control theory, maths, computer science, like that. It will be rotating. So here the thing is 4 factorial into 5 factorial into 2 factorial. Subsequently, we are going to get the first one. And the second one is only mathematics books are together. Only mathematics books are together. So only mathematics books are together means just I am taking mathematics books alone separately, and these books are taking. So this is 7 books, and of course mathematics entire thing I am considering as one book. I am considering it as one book. So total there are 8 books will be there. There are 8 books will be there. So these 8 books I can arrange in 8 factorial ways. I can arrange in 8 factorial ways. So there are 7 control theory and computer science books are 7, and mathematics 4 books together. If I am going to consider as one, together I am considering it as one, then total there are 8 books will be. Total there are 8 books. So 8 books among themselves in 8 factorial ways I can arrange. And after that, the mathematics books internally I am going to arrange in 4 factorial ways. 4 factorial ways. So 8 factorial and internal arrangements are 4 factorial. So that should be done one after the other. That should be done one after the other. So the total number of arrangements. That means for each arrangement, there are 8 factorial. There are 8 factorial. There are 4 factorial arrangements are there of the mathematics books. So 4 factorial into 8 factorial. So these many arrangements are going to be obtained. Next, we are going to prove P of n plus 1 or n plus 1 PR is equals to this. The simple one. Prove that for all positive integers, n comma r is greater than or equals to 0. If n plus 1 is greater than r, then only this. So here, this is the just formula, npr. In the place of n, we are going to replace n plus 1, and we are going to divide with these 2. Subsequently, we are going to get like this. We are going to get like this. So this is, I am going to write it as n factorial, n plus 1 factorial into n minus r factorial by n plus minus r plus 1 factorial and n factorial. This I am going to write it as n plus 1 into n factorial, n minus r factorial by n minus r plus 1 minus 1 next, n minus r factorial into n factorial into n factorial. So n factorial, n minus r, subsequently n plus 1 by n minus r plus 1. So by cross multiplication, we are going to get the required result. Now these are the permutation. Now, what is a permutation is number of permutations when r elements are arranged out of n arrangements is NPR. NPR is n factorial by n minus r factorial that we discussed. Suppose n is equals to 4. Let us A, B, C, D. In that I am going to select two numbers. R is equals to 2. Permutation size is 2. Permutation size is 2. Then how many ways I am getting? 12. 12 permutations I am getting. What are those 12 permutations? I am going to write. Observe this. AB, BA. Next, AC, CA. And AD, DA. And CB, this is BD and DB. And next, CD and next DC. So these are the total 12 permutation I am going to get. Now combinations. What is a combination? It is different selection of a given number of elements taken one by one or some, all are at a time. If we are going to select r elements from n elements, that is going to be denoted as NCR, which is represented as like this. N factorial by r factorial into n minus r factorial. Now, what is the difference between a permutation and a combination? Now, let us say, same for the above, n is equals to 4 letters, r is equals to 2. So, the permutation combination size is 2. Permutation size is 2. Just we are going to substitute n factorial by r factorial into n is equals to 4, r is equals to 2. NCR is nothing but 4C2, which is nothing but 4 factorial by 4 minus 2 factorial into 2 factorial. Subsequently, we can get it as 4 into 3 into 2 factorial by 2 factorial into 2 factorial. So 2 factorial get cancelled. So 6 I am getting. So what are those combinations? AB, AC. See, AB will be there. There is no BA. There is no BA. We are going to select two combinations of size. AB is equals to BA. AC is equals to CA. And AD is equals to DA. See, in the above, say AC is one arrangement, permutation. CA is another arrangement. CA is another permutation. AB is one permutation. BA is another permutation. CD is another permutation. DC is another permutation. Now, here I am going to get only 6 combination. So AB, either I am taking 2 elements, AB or BA, AC or CA, like that. So that is the only difference between these two. So NCR is equals to, I can take it as NC, N minus R. N minus R I am taking. So in the above permutations and combinations, for permutation, AB and BA are two different things. For permutation, AB and BA are two different things. Whereas in the combination, AB and BA are same. AC and CA are same. DB and BD are same. Like that. So now, let us by using the combinations. Out of 7 consonants, 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? How many words of 3 consonants and 2 vowels? How many words of 3 consonants and 2 vowels are formed? So here the total number of consonants are 7. So among that 3 consonants, how many possible ways are? 7C3. Then how many total number of vowels are? 4. So on that 4 or 2 vowels we have to select. So the number of selections are 4C2. So here and both we have to select. So we have to apply the product rule. So either or, if I am taking 7C3 plus 4C2. So here and. So that 7C3 into 4C2. So we are going to calculate this. Finally we are going to get 210. So 7 consonants and 4 vowels will be there. How many words of 3 consonants and 2 vowels can be formed? So here 210 will be there. Now there are 210 groups I am going to get. Where each group containing 5 letters. 3 consonants and 2 vowels. So each group is consisting 5 letters. And 5 letters among themselves, how many possible arrangements are there? 5 factorial possible arrangements are there. So here there are total 210 groups are there. Each group which is having 5 factorial ways. That means the number of each group will have 5 letters. And 5 letters among themselves, there are 5 factorial ways we are going to represent. We are going to arrange. So there are 210 groups are there. Each group is 5 factorial. So there are 210 groups are there. Then total number of arrangements are 210 into 5 factorial. So this is 25,200. Now the another one, let us say in a group 6 boys and 4 girls. 6 boys and 4 girls. Now 4 children are selected. Among these 4 children are selected. In how many different ways the selection is having at least 1 boy? There are 4 boys and 6 boys and 4 girls will be there. We have to select 4 members. We have to select 4 children. The condition is at least 1 boy should be there in this. In these 4 children, at least 1 boy. At least 1 boy means 1 boy will be there. 1 boy possibility will be there. 2 boys will be there. Or 3 boys will be there. Or 4 boys will be there. At least 1 boy means either the group is consisting 1 boy or 2 boys or 3 boys or 4 boys. There are 4 options we'll have. Now, let us say if there are having only 1 boy. So total there are 6 will be there. There are having, let us say, I am just taking from this end, 4 boys are there. The group is consisting all boys. So among 6 boys, how many ways I am going to select 4 boys? 6C4. And next, the second one I am going to select 3 boys will be there. So one is 4 boys and another one is 3 boys means 1 girl will be there. And the next one is 2 boys means 2 girls will be there. Next 3 boys, boys number is reducing. Okay, girls number are increasing. Like this. So now what I am taking the second boy. Second possibility is at least 3 boys. 3 boys means out of 6 C3 and 1 girl. Among how many? 4. So it is 4C1. And the next 2. So 6C2 into 4C2. And the next one is 6C1 into 4C3. So these are the possible ways These are the possible ways. Then, so what we are saying that either this is one possibility, this is another possibility, this is another possibility, this is another possibility. This is one option, this is another, 4 options will be there, or 4 ways. That means we are going to select the number of ways. 4 boys, I am selecting these many ways, and 3 boys, 1 girl, I am selecting in these many ways, and the next 2 boys and 2 girls like this, 1 boy and 3 girls are like this. What is the total number of ways that we are going to select means just we are going to add. Just we are going to add all the above 3. All the above 3. And if you are going to add, then finally we are going to simplify this. Then we are going to get the final value is 209. Final value is 209. So like this we are going to solve the problems. And let us go for the another one is form a group here 7 men, similar thing, 7 men, and the next 6 women, and 5 persons we are going to select. 5 persons we are going to select for the committee. So at least 3 men. The 5 men law, at least 3 men. At least 5 committee members will be there. In that, at least there are 3 men will be there. 3 men will be there. At least 3 men means 3 men will be there, 4 men will be there, 5 men will be there. So whenever 3 men will be there, then 2 ladies, 2 women will be there. 4 men will be there, then 1 woman should be there, and 5 men will be there. There is no lady, there is no woman. There is no woman. See here, how many possible ways? See here, at least 3 men out of 7. 7C3. 7C3. See how 7C3. And the next 2 women. 2 women means 6C2. 6C2. And the next for the 7C4. 7C4. And the next 6C1. 6C1. And the next only men. So 7C5. So just the total number of ways. This is for only 3 men and 2 women. This is for 4 men and 1 woman. This is for committee consisting all men. So the total number of ways that we can form a committee under this condition is just we are going to add, and finally we are going to get the final number as 756. 756. Okay, today I am going to conclude this. Tomorrow we are going to discuss some more concepts in the combinations. So in the next class also we are going to discuss few problems based on the combinations. Thank you. I am going to conclude.
Like, share and subscribe. Hit the bell icon for more updates.